Welcome. Today, let's talk about something critical for businesses and consumers alike: supply chains. In our interconnected world, these networks that bring goods from source to shelf are facing constant challenges. Think about it: geopolitical tensions, crazy weather, pandemics, economic shifts, they all create disruptions. This makes supply chain resilience, the ability to bounce back from shocks, absolutely essential. It's not just about keeping businesses running. It's about economic stability and staying competitive. So, how can companies build stronger, more resilient supply chains? Advanced modeling techniques are key. One powerful tool is network science. Imagine mapping a supply chain like a complex web. Suppliers, factories, warehouses, stores, these are the points or nodes. The flow of goods, money, and information between them are the connections or links. Network science helps us analyze this map. We can pinpoint crucial hubs whose failure would cause major problems, identify weak links, and spot potential bottlenecks. It helps us understand how problems can spread, like a ripple effect, when one part of the chain fails. By understanding this structure, whether it's highly centralized or spread out, we can assess its inherent vulnerabilities. While great for structure, these network maps might not capture the day-to-day operational dynamics fully. That's where simulation comes in. Simulation techniques let us create dynamic models of how the supply chain actually operates over time. We can factor in uncertainty, variability, and how different parts interact. Think of it like a virtual testing ground. Techniques like discrete-event simulation look at processes step by step to analyze efficiency. Agent-based modeling simulates individual players like suppliers or distributors making decisions, showing us how their interactions affect the whole system, great for examining coordination. System dynamics focuses on feedback loops and delays to understand long-term behavior, like the bullwhip effect, where small demand changes amplify upstream. And Monte Carlo simulation uses randomness to model uncertainty in things like demand or delivery times, showing a range of possible outcomes. The real power of simulation is conducting what-if analyses without real-world risk. What if a key supplier shuts down? What if a shipping route is blocked? What if demand suddenly spikes? Companies can test resilience strategies, like holding more inventory, finding backup suppliers, or improving visibility in this virtual environment. They can see the impact on costs, service levels, and recovery times before committing resources. The best results often come from combining network science and simulation. We use network analysis to define the chain structure and weak points, and then use that structure as the basis for dynamic simulations to test operational performance and resilience strategies under stress. It gives a complete picture: structure plus dynamics. Looking ahead, technologies like artificial intelligence, machine learning, and digital twins are making these models even more powerful. AI can improve forecasting and risk detection, while digital twins create live virtual replicas of supply chains for real-time monitoring and simulation. Ultimately, by using network science and simulation, businesses can stop just reacting to crises. They can proactively analyze their supply chains, identify weaknesses, test solutions, and build the robustness needed to navigate the unpredictable disruptions of our modern world. It's about building supply chains ready for whatever comes next.